Hello, my DevNation friends. Welcome to another Tech Talk. Today we have a friend, Bernard Tyson, and he's going to be talking a bit about Kafka and Debezium and the outbox pattern, or how can you do proper messaging with your application using a message broker like Kafka, which doesn't have transactions. So lots of interesting stuff today. So let me welcome Bernard.
Hey,
Bernard,
excellent.
welcome.
Thank you.
So yeah, today here in Raleigh, North Carolina, we're having Hurricane Elsa, or now it's Tropical Storm Elsa. So lots of rain, lots of wind, strong winds today. But how's the weather in Belgium?
Well, it could be a little bit better. We have a slow start of the summer, so it's not really warm still, and still lots of rain. So just hoping that it will get better when the summer advances.
Oh, but at least no hurricanes.
No hurricanes. That's a rare phenomenon here, so we don't really have those.
Awesome. And yes, well, welcome, Bernard, and thank you very much for presenting this topic for us today. And without any further delay, I'd like to say that today, live from Belgium and Cary, North Carolina, welcome to DevNation.
Okay. Good. So I'm Bernard, as Edson said. I live in Belgium, and I'm part of a group in Red Hat that's called, I'm a TMM, a Technical Marketing Manager in the Cloud Services Business Unit. So my job is to evangelize around our managed application services, and this is one of the things I'm going to talk to you about today. So I have a couple of slides, not too much, and then we'll do a live demo. So I'll pray to the demo gods today that they be with me. So I hope everything is going to go well with the demo. So without further ado, let's move to the presentation. So I'm going to go in present mode here. So what I'm going to talk to you today about is how you can use a managed Kafka service together with Debezium to implement the outbox pattern. So I've got, as I said, a couple of slides to set the stage about the different components that will play in my demo. So let's start. So first of all, Kafka. I'm not going to talk too much about that. I think it's pretty well known. Let's say it's an open source distributed event streaming platform, very scalable and fault tolerant, which has a lot of use cases. So typically, all kind of situations where you want to move large chunks of data from one place to another, Kafka is a really good solution. It's also becoming more and more the de facto standard as an event bus when you're developing distributed event-driven applications, and this is exactly the topic of today's talk, or let's say the topic. It has a rich ecosystems around it, so we're going to talk a little bit about Kafka Connect. But there are other things like Kafka Streams, Mirror Maker, but those are not in scope today. Oh, sorry. So one of the issues with Kafka is that as an infrastructure, as a piece of infrastructure, it can be fairly complex to set up, to maintain, to configure. So we see more and more demand for Kafka as a service, so that people can just subscribe to the service. They get like access to one or more Kafka clusters, and they can start using that cluster right away without having to worry about installing and managing themselves a Kafka cluster. So this is exactly what Red Hat OpenShift Streams for Apache Kafka is. So it's a managed Kafka service provided by Red Hat, delivered as a service, managed by our SRE team, so with SLAs of 24/7 and 99.95% uptime. So, but we try to be a little more than just a naked service. So one of the things that we focus on is a very streamlined developer experience, where we have like a UI, which I'm going to show you as part of the demo. We have a CLI that we're going to use. There is an API, And then to connect your applications with Kafka, there is certainly on OpenShift, for instance, you can use service bindings, which will automatically inject the Kafka details in your application. So we really want to provide developers like a first-class experience with our Kafka service. So the current status of the service is it's still not GA, so we expect a GA towards the end of the year. So the current status is development preview. And as part of that development preview, everybody can actually try out the service for free. So no credit card, no commitment required. The only thing you need is a Red Hat account ID, which you can very easily create. And then you follow like the steps that are on this slide, and which I'm gonna go through some of those as well during the demo. And you can spin up a Kafka cluster, which will stay up for 48 hours. So it's kind of perfect if you want to do some quick POC or some test, or you want to just get a bit acquainted with what Kafka is. So it's a very low barrier way of spinning up a Kafka cluster. So the URL at the bottom of the slide, and which you will see repeated on every one of my slides in the bottom right corner, is the URL to get started with this free trial for Kafka. So I certainly encourage you after the talk or whenever you see fit to try it out yourself. So Kafka Connect is like one of the tools that belong to the Kafka ecosystem. So it's a tool to, let's say, in a reliable and scalable way to stream data between systems over Kafka to potentially other systems. So Kafka Connect actually has an API for connectors. So on top of Kafka Connect, you deploy connectors. Those can be source connectors, so they will ingest data from a data source. This data will be transformed into Kafka messages. And on the other hand, you can as well have Kafka connectors, sync connectors, if you want to push data into a sync system. So why am I saying this? Because we're going to use Debezium today, and Debezium runs as a Kafka source connector. Okay, that brings us to Debezium, which is an open source change data capture platform, very popular. So the leading open source CDC platform. And change data capture is all about capturing row level changes to a database, to database tables, and creating change events out of that and passing that into a data streaming bus, which in our case is Apache Kafka. Debezium is a transaction log based, so that means it will tail the transaction logs of the database, which have a number of advantages over some other change data capture solution are more based on polling, but we believe that polling the database tables, we believe that directly following the transaction logs is a superior solution. The downside of that is that every database manages its own transaction logs in a different way. So that means that on top of Debezium, you need a database-specific driver to be able to use to be able to capture changes to that particular database. That also means that Debezium at the moment does not support every database that exists out there, but certainly the most important ones or more prevalent ones. So we support MySQL, PostgreSQL, SQL Server, DB2, Oracle. As far as relational databases go, and we also have a driver for MongoDB. And as I mentioned, it runs on top of Kafka Connect as a source connector. If you want to know more about Debezium, the debezium.io is the website of Debezium, so there you will find everything you want to know about Debezium itself. And this then brings us to actually So a couple of use cases for Debezium is things like data replication. You want to move data from one database to another, for instance, to feed analytic systems, to build a data lake or a data warehouse. It's an excellent fit in distributed event-driven microservice architecture, where typically every microservice has its own local data stores, but other parts of the system might also need to access that data. And typically in microservice architecture, we promote the concept of local data stores and local views. So Debezium is an excellent fit to move data around from one part of your system to others. And then other use cases, auditing, update and invalidation of caches based on changes in the database, full text enablement by moving data, so replicating data from a relational database to a system like Elasticsearch, which is better suited to power full text searches, etc., etc. So basically what, in a nutshell, Debezium allows you to do is build data pipelines where, based on changes that are happening on the databases that you see here on the left, are picked up by Debezium, pushed into a system like Kafka, and then on the other hand, you can have other connectors that will push the data into something like Elastic or a cache like Infinispan or a data warehouse. And all this without writing code. So zero code data pipelines. This is like the comfort zone of Debezium, if you want. And now that brings us to the actual topic of today, and that's the issue of dual writes. So a dual writes happens every time a system needs to update different resources within, let's say, one business transaction. So when we drill down a little bit into the topic of distributed event-driven applications, this is a frequent issue in the sense that what a lot of those services will have to do is persist state in the local data store, and then in the same business transaction, if you want, notify other parts of the system about the change that just happened. So that means, and I have a schema of this, let's say we have an order service component where orders are received, let's say over a REST interface, and what the order service typically needs to do is persist the order in its local database and then send out a message to Kafka so that other parts of your system can consume that message and get notified of the new order that was just persisted. The issue here is that this is a typical dual write. You update two systems. You update your database, you update Kafka, and this cannot be done in one global transaction. Okay, so you do like two, let's say, separated operations, and there is a risk that one of the two goes wrong, and that means that you will have inconsistent data. If, let's say, the order is correctly persisted, so it exists in the database, but for one reason or another, the message cannot be sent to Kafka, now you have an order, but nobody else except the order server knows about it. Or the other way around, let's say that the message is sent, but the persistence, for one reason or another, goes wrong. So that means that there is nothing on the orders table, but now other parts of your system think there is a new order, so you have a consistency there as well. And those kind of consistencies can be very hard to track and to fix into a production system. Solution to that, obviously, is, well, don't do it. Don't do dual write. So just modify only one of the resources in a local transaction, and then have other parts of your system that can drive the update of the other resources that eventually need to be updated based on that first change in an eventual consistent manner. And that's where the outbox pattern comes in. So in the outbox pattern, the service will persist whatever it needs to persist, let's say an order, if we talk about an order service, but it will also persist so the message payload it was going to send to Kafka, instead of sending it to Kafka, it will persist that into a separate table in the database, all this in one local transaction, and then Debezium watches that outbox table, which has the message payloads, captures the changes in that outbox table, transforms that into a Kafka message, and sends that to your Kafka broker. So, but from the point of view of in our case, your order service, there's just one local transaction to the database that completely succeeds or fails. If it fails, there is nothing in the database, no order, but also no outbox row. So that means there will no message will be sent and consumed by other parts of your system. Again, I have like a picture of what this looks like. So we have still our order service, but instead of just persisting orders, we also persist a change event that describes, for instance, the new order into our outbox table. The change in that outbox table is picked up by Debezium. Debezium pushes a Kafka message into a topic on Apache Kafka, and then other parts of the system consume that message. And what's a bit special in what we're going to do today is that in our case here, the Kafka broker is actually a managed hosted Kafka. So I'm not going to install Kafka. I'm going to subscribe to OpenShift Streams for Apache Kafka service to have a Kafka broker. And then wherever the components on the left side or on the right side of the schema run, that doesn't matter. So they can run on premise, they can run in a private cloud, on a public cloud. So the managed Kafka service is reachable from everywhere, so that doesn't really matter. For the demo, I'm going to do that locally on my system by spinning up a number of Docker containers. The outbox table itself has a particular structure, and so it has an ID. It has the payload, so what eventually will end up as a payload for your Kafka message, and then some other columns that are more metadata, which allows Debezium to know what the key of the message will be. So that's called here the aggregate ID column, and the aggregate type. Basically, the value here will be used to know to which topic actually to send that message. Okay, and with that, we can directly dive into the demo. So what I'm going to do in the demo is I'm going to create a Kafka cluster, and then I'm going to spin up a number of containers to power my to power the outbox pattern using a very simple order service. So first of all, let's go. So this is, I'm going to maximize this. So this is cloud.redhat.com, which is basically the entry into the managed Kafka UI. So the first thing I need to do is log in. So you log in with your Red Hat account. If you don't have one, you see like create one now. So this will guide you to the procedure to create a Red Hat account. So my Red Hat account is this one. And then obviously I need to log in. So just grab my password here. This one. Okay. Logging in. So that's the homepage for cloud.redhat.com. You see here at the left in the menu, application services. And in application services, eventually, yes. So you see here, try OpenShift Streams for Apache Kafka, but I will go immediately here and look at my Kafka instance. It's still a beta, so we're in development preview. So yes, I'll use the feature in beta, and that will open a view that will list my Kafka instance, and I don't have one yet because I want to create one on the fly. I could do that by clicking that button, but today I'm going to do that using the CLI we have for everything managed application services of Red Hat. So let me switch to my terminal, and the first thing I need to do here is log in. So the name of the CLI is Rose for Red Hat OpenShift Application Services, and I'm gonna log in. And this login will kind of, it is a browser initiated login because I was already logged in cloudredhat.com. He doesn't ask me for username or passwords. He just reuses that. And it says, okay, I'm logged in successfully. So the first thing I need to do is create a Kafka cluster. So let's do that now. So rows, Kafka, create, and the name, and let's call it DevNation. So that will create a Kafka cluster called DevNation. You get some details about it. Now, spinning up a Kafka cluster will take some minutes. So typically it's 3-4 minutes. So you can follow the status with rows status will typically tell you. So the status is accepted. It's going to go in provisioning, and I can actually follow that on the UI as well. So if I switch back to the UI here, and that should normally have to update itself, but let me refresh the window. Yes, so my DevNation creation in progress, so will take a couple of minutes. In the meantime, I can do other useful stuff like creating a service account. So actually to connect to my Kafka cluster from my applications, I need a service account, which will give me a client ID and a client secret, so as credentials. So I need to create a service account. So while my Kafka cluster is spinning up, let's do that. And I've got here a command which does that. So row service account create, I give it the name DevNation as well. And I will actually save my client ID and my client secret in an environment file so that I can then put it as environment variables in my terminal, so to make my demo a little bit more fluent. And I'm going to save that here in a temporary file. So this will create a service account. So, and again, I can check that in the UI of my managed services. If now I go to service account, you see I have a service account DevNation with the client ID. It doesn't show the client secret, and the client secret you cannot even see. So the way it works, that if I would have done it through UI, I would have to have copied my client ID and client secret in a safe location, because once I accept it, I cannot get it back. I would have to recreate a new service account or reset it. Let's go back to my Kafka instance, see how this is going. Still creation in progress. In the meantime, what I can do is I will add my credentials to a file so that I can source that and use directly in my terminal. So that's this. So that's just for convenience. And now actually, let's do another row status. It's still provisioning. So while it is provisioning, I can start doing other stuff. So what I want to do is spin up a number of Docker, well, actually Podman containers, because I'm a proud Linux user, so I use Podman. But if you have a Mac or Windows, it would be exactly the same as, you could do exactly the same with Docker. So I'm going to spin a couple of components here. So I need my order service with its database. And then later on, I need Kafka Connect, and then deploy a Debezium connector on top of that. So while my Kafka cluster is provisioning, I can provision or spin up a PostgreSQL image. So it's one that I prepared. So as part of the startup, it will create the database and the database table that I want to use. So I'm going to run that. I'm going to name it PostgreSQL. I have a PostgreSQL user and a password, and then a admin password, because the Debezium is going to use for this demo the PostgreSQL system user with this password. And the name of the database it will create, it's called orders, and I use this image which is hosted on Quay.io. So if I do that, it spins up my Postgres container, and I can tail the logs, SQL, like this. Oh, I need this, sorry, Podman, of course. And you see that it's up and it created, you can see here, like it created the tables that I set it up for. So actually we can very quickly verify what's in my database. So let's enter my container and then with SQL and then connect to my orders table and then do so you can see that I have a sequence and two tables. The tables called orders, where I'm going to persist my orders, and my orders outbox table. And if you look at my orders outbox table, you will see that it has like 1, 2, 5 columns. There's an ID, which is auto-generated, the aggregate type and aggregate ID, which Debezium needs, the payload, where actually I'm going to paste the payload that I want to send ultimately over Kafka to my consumers, and then the content type, which will end up as a header on my Kafka message, which will actually specify which content type I use for my payloads. So my PostgreSQL is ready to be used. So let's check. Oh, and in the meantime, my Kafka cluster is ready. So that's also reflected in the UI. So now what I still need to do here is create a topic. And again, I can do that from the UI, but today let's do that from the CLI. So I'm gonna create a topic for my order event Kafka messages. So basically with the row CLI, create Kafka topic. I choose 15 partitions. This is like just for this demo. So it's more than enough. I could have done 1 as well, but I tend to default on 15 partitions. And I choose to a retention time and retention size like unlimited, knowing that my cluster will disappear in 2 days anyway. So I'm not sure I mentioned that, but yeah, I think I mentioned that when you do a Kafka trial through our service, your Kafka stays up for 2 days and then is recycled. So that means that it doesn't matter how long I retain my messages, within 2 days that cluster is gone anyway. So I create a topic. Yes, so it spins up like a YAML file, but I can also verify that on the UI. If I click here on the name of my cluster and to topics, you will see I have an order event topic with 15 partitions. Everything is set on the Kafka side. So you've seen how easy that was, just spinning up a cluster. So now I need to spin up my order service. So I have a podman command for that as well. And again, I use an image for that. So this image here, it's the order service is a Quarkus application, and it takes some parameters to be able to connect to my database. And also this order event, that will be the name of the topic I want my order event messages sent to. So this is configurable here because I implemented it that way. And you see there is nothing, the order service does not know nothing about Kafka, right? It only knows about the database. So I'm going to spin it up. If I tail the log of the order service, you will see that. Oh, sorry, again forgot Podman here. Sorry for that. We'll see it spins up. It's a Quarkus application, so it spins up like very quickly. So in less than 2 seconds. Well, actually here it was a bit slow, 4 seconds. But in 4 seconds it's ready to be used. I'm gonna leave that here. So let's then move to yet another window. So now what we still have to do is spin up Kafka Connect. So Kafka Connect takes a configuration file, which I'm gonna paste that to. I'm gonna put that in a file, and that's where my Kafka details come in. So Kafka Connect needs to be able to connect to my hosted Kafka server. So it needs the Bootstrap server, and it needs my security details here. So it needs the client secret and the client ID and the client secret. So if I create that file, and I hope because that went okay. So that was mentioned. Oh no, that's not the one I wanted to show. Sorry, it's the which was it? It was the Kafka Connect. So sorry, window. And connect. Dash properties. Yeah, that looks. Does that look okay? I think it looks okay. Yes, it looks okay. So we can now deploy or Kafka Connect image. So where again I use a prepared image, so which has already the Debezium libraries and the Debezium Debezium libraries and PostgreSQL driver installed on top of it. So I'm going to mount my properties file in there so that I can configure automatically my Kafka Connect instance. So there you go. And then if we tail the logs of my Kafka Connect container, I see, whoa, it didn't work. Whoa, what did I do here? Oops. It doesn't find my Bootstrap server. That's not good. No resolvable Bootstrap. So let's stop the container. So I'm sorry for that. The demo gods are not with me today. It's without this, I won't be able to show you anything. So, and let's see what. And let's verify my properties file again. Properties. Oh, it doesn't have. Oh, yes, I know what it is. Sorry, I forgot to add my Bootstrap server to. I need to do. Okay, so that is just one command away. Let's do this. Let's go here. I know. Sorry, a little bit nervous here. I shouldn't, but it's annoying when things don't work. Copy. Yes. Okay, so now if I go here and I do echo Bootstrap. No, I need to open a new window for that to source it. Okay, echo Bootstrap. Now it's set. Okay, so now I can do that Kafka Connect command again. and spin up my image. And this should then work as expected, at least I hope. There we go. Next. Connect. So I still have issues here. I really don't know what's going on. Although it seems that that's weird. Is it my Oh no, the store is fine. Plain SSL is fine. So I don't know what's going on. It worked this morning. So I also see that we're running over time. So I'm afraid this is not going anywhere. I'm very sorry about that. So
No worries. It happens to everybody.
Yeah, it seems it cannot connect to my Kafka cluster. It needs to Connect needs to create a Kafka admin client, and that doesn't seem to work, because normally what you would have seen is that new topics, Kafka Connect needs its own topics, and they should be created automatically. But that doesn't seem to work here, and I honestly don't have a clue what's going on. So the only thing I can still think is that there is something wrong, something missing in my...
It seems to be missing the bootstrap URLs.
No, this one? Yeah, it's still missing the bootstrap. Oh yeah, I need to recreate that file. Oh my God, of course. So if I can still have a couple of minutes, I can...
Please go ahead. We want to see it working, yeah?
But now I did something weird. Okay, so I will recreate that file. Okay, and I'm gonna do the book. So yeah, that's... See, now it has it. Then oh shit. Properties. Does it has it now? Now it has it. Okay, so I'm gonna stop my container again. Connect. Remove it and spin it up again. Okay. Take my command for that. Now I'm pretty sure.
Fingers crossed.
I'm pretty sure.
Fingers crossed.
Yes. If not, there you go.
I can see some people cheering for you. So let's do it. Let's do it.
That's a lot better. That's a lot better. So lots of logs spinning up. You will see some topics appear here. I think I need to force a refresh. There you go. So Kafka is creating its own topics. So we're good now. So what I need, I can stop the logs here. So now I need, and that's the last thing before, well, there are a couple of things. So we still have time, Edson?
Yes, go for it.
Yes. So now we need to configure the Debezium connector. So basically so I'm going to deploy, so Kafka Connect has a REST API, which you can use to deploy connectors. So this is so it takes a JSON file with the configuration of Debezium. So it uses the Postgres connector, how to connect to the database, which in the table whitelist, which table to actually look at, so orders outbox. And then it does a single message transform. So to transform the raw change event into a Kafka message, which is built into the Debezium, it's called the event router. And then basically those two last lines is what to do to figure out to which topics to send. And then this one actually tells what you see in the content type table. Put that as a header in your Kafka message with name content type. So that is my Debezium configuration. And now I can do a curl command to actually deploy that. There you go. So that is successful. So Debezium is now, and actually, if you look at the logs of the logs -f connect, you should normally see some additional things like this. This whole thing means that Debezium could connect to my database. So the last thing I need to do before I can do a test is have a consumer so that we actually can see messages going back and forth, but actually forth, not back. So I'm going to use Kafka Cat for that. And so I'm going to spin up a Podman container with Kafka Cat, which also will connect to my Kafka broker, obviously. So by doing that, this will spin up the container, and you see I'm listening to the topic order event, but there is nothing in that topic. You don't see anything. So, and that's the absolute last thing I need to do to actually demonstrate the whole thing is create an order. And for that, I can use, so my order service exposes a REST API. So with a post, I can create an order, which consists of a very simple JSON structure. So I kept it simple. So if I do this post, you get a 201 created. And now I should see a message. Yes, so this is Kafka Cat, who now got a message with a payload, which I built in my order service, and it's persisted in the database, picked up by Debezium, sent to Kafka, and consumed here by Kafka Cat. If I do another one, you will see another one in my Kafka Cat in a other partition because it has another key. So the first one, partition 13 and partition 3. So this kind of demonstrates the whole thing. So I basically, just to recap, I persist my order and a message payload by my order service in the database. Debezium picks up the change in the outbox table, converts that into a Kafka message, sends that out to the order event topic, from where it can be consumed by consumers. And all this using a managed Kafka service, so that was really easy to spin up. So that concludes my demo and actually my presentation. So I can quickly go back to my presentation. So that was a demo, and I'm sorry that it took a little bit longer than I was hoping for. So you see a number of other resources. So everything I use, my code for the order service and stuff like that, can be found in this GitHub repo or organization. Again, if you want to try out the Kafka service, this is the link. Oh, sorry, I inadvertently clicked it. There is a YouTube playlist around everything OpenShift Streams for Apache Kafka that you can find here. I published yesterday, was one of my blogs was published about getting started with the service. And if you're interested in Debezium, Debezium.io is where you can find everything. And that was it for me.
Awesome. Thank you, Bernard. I'm glad that your demo worked in the end. You know, sometimes that demo gods wants to play with us. So
yes, exactly.
But it worked. Yeah. And I can see here Gunnar Morley, who is the lead for the project lead for the Debezium project, is already on the chat, and he was able to answer one of the questions. And just to reply the question here, which was, does Debezium guarantee exactly once or at least once? And Gunnar was able to answer that it's at least once. Depending on the situation, you might have duplicate events. And also, I'd like to point out, since we're using Kafka in the backend, Kafka already is at least once broker. So you might have duplicates. But for the other question, and maybe even Gunnar can reply that on the chat, I have here this one. Can you use Apache MQ, ActiveMQ, instead of Kafka as a broker with Debezium? Tony O'Donnell is the one that asked this one.
Would I can take that, but Gunnar can maybe go more into details. But as far as I know, the answer is no. So Debezium is well, Debezium can run in two modes actually. So the way I show it, it runs as Kafka Connect, so that is tied to Kafka. But Debezium can also run in an embedded mode, and then you have a lot more freedom what you actually do with your change event. So in that case, it could use another messaging system or even no messaging system at all. Then it's up to you how you treat that change event that Debezium picks up. But if you run it as a Kafka connector, then you're kind of tied to Kafka as a messaging bus.
Awesome. I didn't know that. I thought it was tied to Kafka. So thanks for letting us know. And we're already on top of the hour. So, but thank you, Bernard, for this amazing presentation. I enjoyed a lot. I'm sure all our audience enjoyed a lot as well. And hope to see you in another DevNation opportunity. Who knows?
Yes, I would very much like so. Yeah, this was fun.
Okay. Yeah, thank you very much. Thank you, Bernard. Thank you for watching us. And stay tuned and see you in our next DevNation offering.
Okay, bye.